Hello everyone. Today I will discuss on probability. Use of probability in data science. Let's start. First, we have to know what is probability. I hope many people know that. In one sentence, we can say what is the chance of happening something, right? We just give a number. Let's see the equation of the finding the probability of basic thing. It is a favorable outcomes by total outcomes. Okay. For example, rolling a dice. We know all what is dice. Dice have actually 6 sides, okay, and each side have different numbers from 1 to 6, right? 1, 2, 3, 4, 5, 6. Okay, so 6 total number. That means total outcome here actually 6. Now I will try to find the what is the chance of getting even number if we draw a dice. And in a dice, 3 number actually are even, 2, 4 and 6. So favorable outcomes become 3. So finally, what is the probability? If we put all those number in the equation, we'll get 3 by 6 equals to 0.5. So this is the chance 0.5 is the probability of getting even number. Okay, so that means 50%. If I transform in this number into percent, then you will find the 50% chance getting even number. So actually the probability number, you can see it is now 0.5. Actually we get number between 0 to 1. The number probability should be greater than equals to 0 and less than equals to 1. If we get 0, that is impossible. Means it is impossible to happen something. And if we get 1, that means we 100% sure that it will happen. Okay, and in between, not fully 100% sure, but just some percentage of percentage we are quite confident that this thing going to happen. Like 0.5 means 50% chance to actually we I mean if we draw a dice, we'll get even number. Fine. Now come to the why probability in data science. It's a very important thing. Why actually we need probability in data science. Because main thing actually real world actually uncertainty. Yeah, like we are never 100% sure will it rain, will a customer leave, is an email spam. You cannot say yes or no with absolute certainty, right? Next is core of prediction. Like data science aims to answer what is like to happen. Instead of guessing customer will leave, we state customer has 80% chance to leave, right? Actually, we need some number not any sentence like that, right? Because we know, as I've shown you, the probability gives a number. Now last one is decision making. Yeah, definitely. So companies rely on the probabilistic output to take concrete actions. Okay, utilizing threshold to automate their business operation effectively. So actually, this number are very important to the decision maker of any business. Okay? So these three key things why probability need in data science. Now, just try to make you understand how it's help in data science. Okay, let's 90% chance of fraud. Okay, after applying probability, if you get 90%, you got 90% chance of fraud. So then what decision will take by business? I mean block transaction immediately. Definitely. If 10% chance of fraud, then allow transaction to proceed. Another example, 80% chance of churn, offer targeted retention discount. Okay, this line means actually like suppose one customer entered into a portal of retail portal, right? Like Amazon, Flipkart. Okay, what is the chance of customer will stay and buy something, right? 80% means chance of churn means 80% chance of churn means 80% chance of customer leaving the portal without buying anything, right? That's why obviously business will try to give more uh, discount to the specific set of customer so that to reduce the churn. Okay, sorry. Now last example is 95% chance of spam. Definitely route email to junk folder. Actually spam mean to message or email. This is actually example of uh, output of the probability in data science. This is the output which is actually or numbers we get from the probability, and business actually use like this way. Okay. Now, just for now, just know that uh, what are the models actually use probability and what are the model not use probability. Actually, I want to mean that all the models, ML models, not use probability. What is model? Actually, model is a, you can say, a system which learns pattern from data during training time period and can take the can predict the output of the new data. You can, this is actually model. Okay, so let's see some base model which use actually probability in their calculation. I mean to predict the output. Okay, one example, logistic regression, naive Bayes neural network. these three popular ML model use probability mathematics to predict their output. And now non-probability based model, I mean, there is K nearest neighbor, decision trees, support vector machine. These three popular model not use probability mathematics in there to calculate the output. I will discuss all these models later in other video. Step by step, actually try to make you understand what you need in data science. Okay. So later at stage, I will explain everything, how to make this type of models, how to train a model. I'll discuss later. For now, just know that all model not use probability. Now coming to the conditional probability. What is this? The probability of an event A happening given that event B has already happened. The core concept is that the condition effectively reduces the sample space. That means you don't need to consider all the sample space. Okay. That means all the outcomes. Only the specific set of group of outcomes you need to consider. And based on that, you need to predict or calculate the probability. Right? For example, if there is a two males in the group and one passes, the reduced sample space is just the males. The probability is 1 by 2. So you don't need to take care about the female as well. Yes. Only you need to consider male, because what is actually in this example we are trying to predict the what is the probability of the passing of male candidate. Okay, so this is the example of conditional probability. Now independence in probability. This is the equation PA probability of A into probability of B. What is this? Actually, here events not affecting each other. Here multiple events present, but they do not affect each other. Two events are definitely independent if the outcome of the one does not influence or affect the probability of the other. Example, suppose you're rolling a dice and flipping a coin. Both are independent. So probability of rolling a specific number is 1 by 6, because 6 is total. In the previous example, I have shown that what is the rule of the equation of the basic probability. The total outcome, sorry, the let me show you, okay, so that you can understand favorable outcome by total outcome. This is the equation of the basic probability. Okay, so here, any number will not stick to any even or odd or any specific number. So any number. So that's why favorable outcome is 1 and total outcome is 6, 1 by 6. And probability of flipping heads in a coin, obviously one head present. That's why chance favorable outcome is 1 and total outcome is 2, 1 head and 1 tail. So that's why 1 by 2. Now as per the independence probability equation, we need to multiply these two probability. So 1 by 6 you multiply 1 by 2, that is, so total probability is 1 by 12. Okay. Now Bayes theorem, what is very important? It is actually update your probabilistic belief using new emerging evidence. Suppose you know some probability, okay, you have a probability, but when in new data comes, so you have to modify your probability as per the new evidence. Actually, this is the thing um, as per the Bayes theorem. Okay, so let's see this equation PB by A, PA and PB. Okay, so what is the mean of PA? PA means what you believe before the evidence. Okay, PB by A, how strong the new evidence is or likelihood. Can say. What is PB? The overall chance of that happening, evidence occurring. Okay, and PA by B, your final or updated belief. So this is the meaning of the all these things present in this equation. Let's move to the next screen so that you can understand everything. So I am trying to make you understand by giving an example. It is a let's spam filter, whether SMS or message is spam or not. How can you identify using Bayes theorem? So our goal is spam based on the word win. If I see the word win, what is the chance of that email is spam? Is win what is present in that message? What is the chance of the email is spam? Right? Suppose you have 100 emails, total 50 spam and 50 not spam. Okay. So that means what is the total chance of spam? Is 0.5 because 1 by 2, because spam and non-spam are equal. So that means 1 by 2. And evidence, how we calculate? Evidence means what doing, so appears in 40 spam emails and 5 regular emails. Actually, win word is appears in 40 spam emails and 5 regular emails. Right? So what is the probability of win word is present in spam message? 40 by 50. 50 is the total spam message and 40 is the as the win word is present in 40 spam email. So that obviously it should be 40 by 50, 0.8. 40 is actually favorable outcome and 50 is the total outcome, right? As per the basic probability law. So that means probability 0.8, mean 80%. Now, what is the total evidence? Total evidence means 50 plus 50, 100 in 100 ml. How many email contains the win put? Win? What win? So 45 total emails have the what win, because in the point 2 is mentioned that appears in 40 spam email and 5 regular email. Average 45. So what is the actually overall chance of win in the message? 45 by 100. I mean, total favorable outcome by total outcome. It is 0.45. So as per law, evidence into spam, that means old belief. What is the belief before the evidence? That is PA, and likelihood BA by PP. PB overall the chance of evidence occurring. So that's why PA, right? It is the PA, sorry, PA 0.5 and sorry, PB by A likelihood, that is 0.8 evidence, and by total evidence, that is 0.45. So total, I mean actually the value is 0.89. This is the answer. Final answer is 0.89. So what is likelihood? Let me explain more details. Word by spam. So because how often a specific word appears strictly within the set of spam. This is called likelihood. How often a specific word appears strictly within the set of spam. Okay. Now in this bias theorem there is a problem. It is called zero probability problem. What is it? Suppose specific word not present in the message. In that case, the probability is 0, definitely. Suppose win word is not present in the message. That means it will give you 0. So actually this thing actually cancel out all the probability. That means your total probability becomes 0. If you observe the Bayes theorem, we have used multiplication, right? If P by A becomes 0, that means all become 0, right? So how to resolve? So that's why the solution is actually Laplace smoothing, just by adding 1 to the every count. Whatever probability we get for PB by A or P win by spam, just plus 1. Okay, this is a zero probability problem we solve using Laplace smoothing. So that's all for today learning. And if you have any query, you can post in the comment. I'll discuss in the later recording or next recording, and I'll create more tutorial on this probability later on if needed. So till now, these are the probability things actually needed for your data science. Okay. In the advanced stage, if need more things, I'll definitely will discuss those things. Okay. So see you in the next recording. Thank you. Bye.